Hello and welcome to my channel. Today we'll be talking about rate of change, okay, another aspect of differentiation. All right, so I have a couple of questions here that I believe will help us to really understand what rate of change is all about. Okay, so we will start with the first question. It says that a cube, all right, I like to read and underline important things. A cube, first I need to know what cube is, has side x, and the surface area is this. The volume is increasing at this particular rate. So if the volume is increasing, then it means that dv dt, okay, because the volume is definitely going to increase with time, all right? So dv dt is 480. Fine. The question says that at the instant when find at the instant when v is 0, the rate of change, the v is 512. We should find the rate of change of what? Of the x. Okay, so that basically means that x is increasing, but with respect to what? To time. All right, but basically this is what I want you to do. Of course, you're going to use the chain rule, but I need you to write the numerator here, and then let's get our multiplication sign here, and then write the denominator here. All right, now ask yourself, what information have you been given already? Now if you check, you've been given dv dt. Okay, so that means that you can work with respect to volume. So put dv here and then put dv there. Okay, then we go back to the question. It mentioned cube and says the cube has what? A surface area. So for a cube, let's call the surface area S. Cube has 6 faces and each face has an area of x squared. All right, so that is for the argument. Anyways, now we are told that the volume, there's a volume for the cube, right? So V is equal to x cubed, okay, because it's 3 dimension, x times x times x. All right, so from here we can differentiate the volume, and then we will know that we have 3x squared, right? Okay, so if we have 3x squared, then we can put, we have dv dx, but here's dx dv, so it flips. Okay, so we have 1 over 3x squared times dv dt that the question gave to be 480. However, there's an important part that we need to consider. We have already argued that from the question, of course, we know that volume is this and then volume is that. So we can equate the two volumes. So s cubed is equal to 512. You take the cubic root of that, and then calculator tells you your answer is 8. So now you can find the rate of increase of x. You know what the value of x is, so you can just put it there and then you'll be good to go. So if you put 480 over 3 into bracket 8 square on the calculator tells you your answer is 2.5. okay, so this is how to basically go about it. All right, good. Then the next thing that you want to do is that they want you to find the rate of increase of s. So that is ds dt. Okay, like I always do, you write the numerator here, the s. All right, bring your multiplication sign here, dt. Okay, so definitely we need to put some value here and that same value there. But what do? Well, go back, see the s. The s that they gave us, this particular s comes in relation to small x here. So when you differentiate, it will become ds dx. Okay, so that means that you can change this guy to dx and then dx. All right, so if we bring that argument down here, it's a 6x squared, and we differentiate, we are going to have 12x, right? Great. So you have your 12x here and then times dx dt. Now dx dt is exactly what we have found here to be 2.5. So times your 2.5. Okay, in fact, let me make this thing times, then I put into bracket 2.5 so that there wouldn't be too much of the dots there to confuse anyone. All right, but now at this stage, you'll be wondering what is the value of x? Well, you found x already over here, and you got x to be 8. So just put 8 there, and you are good to go. So you have 12 into bracket 8 times 2.5. All right. So we have 12 into bracket. All right, 8 times 2.5. The calculator tells us that our answer is 240. Okay. All right. Now let's go to the next question and see how you apply this knowledge too. So the next question says that the volume V of a sphere of radius is given by V is equal to 4 over 3 pi r cubed. Okay. Now we are also told that the radius, all right, which is r, of the sphere is increasing at this rate. So that means that dr dt is 0.5. Okay. Now they want us to find in terms of pi the rate of change of the volume. Okay. So they want to find the rate of change of volume. Volume changes with respect to time. So we have the v dt. Okay. Like we always do, you put the v here times something dt. Okay. So we are here to look for what we put there. All right. We have the volume here. So if we differentiate volume, we get dv dr, right? So we can just comfortably put dr here and then put dr there. Okay, so if we differentiate that, we are going to get 3 into 4 pi r square over 3, right? Times, we got dr dt. They told us that dr dt is, let me make it times dr dt, which is 0.5. Okay, then the question also went ahead to tell us that the radius is what? 0.25. Okay, right here, 0.25. So we can put it there, and 3 times, so check this thing out. This will cancel that, so we have 4 pi into bracket 0.25 square times 0.5. Okay, so you have 4 times 0.25 square times 0.5, giving you 1 over 8. Okay, 1 over 8 pi, or you can also say 0.125 pi. Okay, and you are done. So that's how you go about it. Let's now look at this particular question. It says that the radius of a circle is increasing at this rate. Now the radius is what? R. So you can write dr dt is equal to 5 cm cube per second. Okay, then the next thing that they want you to do is to find in terms of pi the rate at which the area of the circle, right? So now they want you to find the a dt, right? The area of the circle is increasing when r equals 3. Well, if they want you to find the a dt, then that means that you put your dA here, okay, times put the dt somewhere there. We'll come up with whatever is happening. Right now, they said the area of a circle. An area of a circle is giving us pi r squared, right? Good. So if we differentiate the area of the circle, we have dA dr, right, giving us 2 pi r. So that means we can use the r here, and then we can use the r there. Okay, now they said that the radius is what? Is 3. So the dr at r equals 3 will be this into bracket 3, all right, giving us 6 pi times the r dt. Now the question already gave us the r dt to be 5, and that 6, 5, 30, so we have 30 pi. Okay, and then you are good to go. The marks are really big, like 4 marks and things like that, but I mean the workout is pretty straightforward, very simple. All right, now we have this particular question. At a glance, you might think that this question has nothing to do with rate of change, but if you come to this particular question, where is it? Good, this one that says that given that A is increasing at this rate, blah, 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 find the corresponding rate of the R. That is the main reason why I want us to solve this particular question. Okay, so it says that the diagram shows let me get some red. Diagram shows sector OP Q where the radius is 3 from O to Q, that's the radius of 3. They give us 2 here, they give us 1 there, making 3. Okay, all right, let's continue. The points S and R lie on OP and OQ. Obviously we see this and that, and then they are telling us that it also forms a sector. So this whole thing, all right, it's also a sector. Okay, let me clean that, it's terrible. Okay, then we are told that that sector has a radius of 2r. Obviously we can see that, and then the angle that they subtend at the center is called theta, and then the perimeter of the shaded region is 100 cm. So this whole thing, all right, is 100 cm. What do they want? Find theta in terms of r, of course. So what you want to do is to be interested in the perimeter, because that is what you know as of now. Okay, so how do you find the perimeter? Well, you need this side, which is also r. Okay, because if this is r, then that is r, but you are left with this part and then that part. That's the arc length. All right, and the formula for arc length, in case you've forgotten, arc length is what? R times theta, the radius times theta. Okay, so let's find the arc length of PQ. That will be the radius, which is 3r times theta, then plus this side. So we are done with here. This is r. Okay, then plus this side, that's the arc length of SR. So that will be, that radius is 2r times the angle theta, plus finally this side, which is r. All this should give you 100. Okay, so now you have 5r theta plus 2r is equal to 100, and that should give us, they said find theta. So you move the 2r to the other side of the equation, divide both sides by 5r, and this is what we get, okay, for your 2 marks. They said hence show that the area of the shaded region is that. Well, for area, what you really want to do is find the area of the bigger sector, okay, and then subtract that by the smaller sector. In case you've forgotten how to find the area of a sector, is given by half r squared theta. Okay, so let's look for the bigger one. That's half r squared, right? But that radius is 3r, so 3r squared theta minus, then we look for the other one, which is half, that radius is 2, okay, r, the theta, all right, and then when we check this now, we get 9 over 2r squared theta minus, this will be 4 r theta over r squared over 2. Okay, so that's the area that we are working on, and this will be, let's say 4.5, right? 4.5 r squared minus, this cancels this 2, so we have 2r squared theta, and that will give us 2.5 or 5 over 2 squared theta. But you know, this is what we have, but the question says we should get something like that. So the next thing you have to do is to check this thing out. What was the problem? The problem is the theta, but we know what theta is. All right, so that 2.5 is the same as 5 over 2 r squared. Theta is now 100 minus 2r over 5r. Okay, so we can expand that, and we are going to get 500 r squared minus 10 r cubed over 10r. Just factor out 10r squared in the top, or just 10r. I think 10r will do. So you'll be left with 50r minus just r squared over r, this guy, and then you can comfortably cancel out, and then your answer is 50. Area is actually 50r minus r squared. All right, and that is what they wanted us to find right here, and we have proven that for how many marks? 2 marks. Okay, all right. And then the next thing that they are telling us is that given that r can vary, that means that you can differentiate with respect to r, and that a has a maximum value. Find the value of a. Well, that's That's okay. We can work with that. So if so we have our A to be given as 50r minus r squared, right? So the R would be 50 minus 2r. Now they are telling us that A has a maximum value. That means that the R should be equated to 0. And when we do that, we have 50 minus 2r equal to 0. That means that we have 2r is equal to 50 and r is 25. Okay? So if you want a maximum value of A, then put 25 into A. So you have 50 into bracket 25 minus 25 squared. The next thing is put everything on the calculator. So 50 to 25 minus 25 squared will give you 625. So that is the maximum area. Okay. Now they go on to say that given that the area is increasing at this rate, so that means that the T is 3. Okay. At r equals 10. Okay, definitely they have given us r equals 10. Now they want us to find the corresponding rate of change of r. So they want us to find the r dt. Okay, so right now let's put the r here times the t there, and then we are left with the variable that we are going to differentiate with respect to. But take your time. You already know they are talking about area, and we know that this is area, and we differentiated it and we got the r, the a. So we can just flip it and put the a here and put the a there. All right. So we have already differentiated it, and we know the a, the r gives us 50 minus 2r. Okay. So that means that the r, the a, okay, you flip it, so you have 1 over 50 minus 2r times the a dt, which happens to be 3. Okay, but we know that the value of r is 10, so we can rewrite this as 1 over 50 minus 2 into bracket 10 times 3. Okay, and that will be 3. Sorry, let me just write the whole thing. The r dt will be equal to 3 over, that's 50 minus 20, that's 30, that's 1 over 10, or 0.1. Okay, for your 3 marks. Now they said that find the corresponding rate of change of theta. So now they want us to find the theta dt. Okay, but let's go and check something here. I remember we found theta gray. So this is theta. Let's copy this, then go and put it right there, probably here. And then squeeze it a little bit. Okay, so we know what theta is. So even if we want to differentiate, let's say we want to differentiate theta, okay, we are going to use the chain rule, the quotient rule. Okay, so what happens is that we differentiate the numerator and we get -2, and then we keep the denominator constant, minus, now we keep the numerator and we differentiate the denominator, we get 5 divided by the denominator square, 5 square, and that will give us a -10r minus into bracket 500, minus 10r, which would all over 25r squared, right? And that will give us -10r minus 500 plus 10r over 25r squared. So definitely this and that will cancel out. So we are having -500 over 25r squared, and 500 divided by 25, that's 20. So we are looking at -20r squared. Okay. All right. So we have this guy, but let's complete this guy. So that's the t times the theta times the t, and now we know that when we differentiate theta, it comes with what? The radius, right? So we can put the r here, the r there, and we have already done that. The r the theta, the theta the r, we got -20r squared times now the r the t. What is that? Well, check this thing out. The r the t, we found it. That is 0.1, so you can put 0.1 here. But what is the value of this particular r? The question said that is 10. So we can modify it and write -20. Hold on, let me see. Yeah, sure. So we have -20 into 10 square, all right, times 0.1. All right, and then that will give negative 20 into 10 square times 0.1, and that is about negative 200. All right, so but this value seems too big. There's something weird. Have we made a mistake or something? So let's see if the differentiation is correct. I think everything is fine. So what seems to be the problem? Okay, let me check something out a little. They said this is 10, okay. So minus 500 plus 10 into 10 over 25 into 10 square. Oh, okay. That what seems to be the problem. If I put 10 here, calculator gives me negative 0.2. Right. So, oh yeah. This is not true. Check this out. This is not true. Actually, this is going to be negative 25 over r squared. So this is wrong. That is why the value looks too big. Right, sorry about that. So you get negative 25 over r squared. And we said r is 10. So we have negative 25 over 10 squared, which is 100. Okay. So that's what we are going to work with. Oh, it's actually 20, not 25. Why am I making mistakes like that? 20. Okay, so that means that we have negative 0.2 here times 0.1, and then calculator says your answer is negative 0.02, right? Sure. 0.2 times 0.1. Yeah. Okay. So that seems to be the case. Okay. Now let's check this question out. I think this will be the last question that we are going to solve. A circle has a diameter of x, is increasing here. All right. And so you can say the t is 0.01. Okay. Find exact. So exact means that they don't want to see any decimal. Just leave your answer in pi or something, you know. So find exact rate of change of the area. So they want the a dt. Okay, you hold on before we split this. Okay, you now we can just put the a here times the t there. We don't know the values that we will put there, but let's hold on a little bit. They are talking about the area of a circle. Area of a circle is given by 2 pi. No, that's actually pi r squared. Okay, but remember that the radius is, they are talking about diameter in the question, so radius will be x over 2, diameter divided by 2, because they said diameter is x, so you have to divide that by 2. Okay, so if you divide the diameter by 2, then that means that you can modify this particular thing. Let me just bring it here. You can modify it a little bit. Okay, you have now is dx dt. That's the derivative of the rate of change of the diameter with respect to time. You can change it to the rate of change of the radius by dividing it by 2. So 0.01 divided by 2 is going to give you 0.05, right? Something like that. Let me confirm with my calculator. 0.005. Okay, so now you know what happens in terms of radius. And now if you differentiate the area too, you get the ADR. So you can put the R here, put the R there, and that'll give you 2 pi R. Okay? All right, and then they said that the X is what? Is 6. So you have 6 over 2, that means radius is 3. All right, so the ADR, we got 2 pi R, but radius is 3 times the R dt, and that is 0.005. That is 6 pi times 0.005, and that, put it on calculator, will give you 0.03, and then you just add a pi. Don't include a pi because they said that get your answer in the exact form. Okay, so this is where you end your calculation. Don't write it. Don't put a pi on the calculator and then find the value. You'll be wrong. Okay, so this is exactly where you end. Right, so I'll link this particular worksheet in the description. Give it a try. If you find this video useful, give me a like. Other than that, you can also register your displeasure in the comment section. See you again next time.